Hey guys, I am Gautam and welcome to Easy. In this video, I am going to talk about chemical thermodynamics and important questions from this chapter for IIT JAM 2019, right? So the basic topics are reversible and irreversible process, first law and its application for ideal and real gases, thermochemistry, that is the application of first law, second law, entropy and free energy, and finally criteria for spontaneity. First, I want to tell you that except these which are in the syllabus, some other topics are also included. For example, free expansion or free compression, this is not included. Only reversible and irreversible processes are included, but in IIT JAM exams they often asks questions from free expansion or compression, right? So you have to read the whole thermodynamics, and I will provide you the study material regarding the thermodynamics, chemical thermodynamics especially. So just check my blog in the video's description, and you can collect that material from there, right? So let's talk about different years questions and the pattern of questions so that we can get ideas of JAM 2019. Okay, so first JAM 2014, right? So 2014. So what was the first question? The change of entropy for the following transformations is respectively plus includes plus says increase and negative says decrease and zero says no change. So in the first reaction, one gaseous molecule converted to two other gaseous molecules, so here entropy is increases, so it is positive. Second case, n number of ethylene molecule forms one polymer, so it is here entropy decreases. So here number of molecules in the product decreases because one polymer is formed, so the entropy here is negative. So then the third reaction, solid to vapor, that is solid to gaseous state conversion, so here entropy always increases, because the disorder number of molecules increases in the product, so the disorderness increases and the entropy also increases, right? And the fourth expression, that is adiabatic reversible expansion. This is adiabatic process, and entropy, that is delta S equals to Q by T. So Q actually reversible, so if adiabatic process, Q will be 0, so entropy will be 0, so the D, so the answer will be correct, that is positive, negative, positive and 0, that is entropy increases, decreases, increases, no change. Okay, in the respective four systems you will get the different IIT JAM exams answers, explained answers in my blog, so check there, you will get the PDF and download it, and you can collect all of this. Okay, in JAM 2014 there was only one question. So coming to JAM 2015, the question was for an isothermal free expansion of an ideal gas into vacuum, that is, it is free expansion, right? Which one of the following is correct? So this is free expansion, and in case of free expansion, P external equals to 0, so work equals to 0, and isothermal, that is temperature equals to 0, so delta U will be 0, and these two are correct. So in the four option, the options C, in the option C, delta U equals to 0 and del W equals to 0, so we need not to consider Q because there is only one option which is C, in which delta U and W both are 0, so option C will be correct. You need not to consider Q, right? So this is the trick. You don't know the answer, but you can guess the correct answer, which will be exactly correct, right? Now coming to next question, which is correct? So this is from Maxwell's relations, and you need to consider Maxwell's relation. This is S, P, T, V. So here is in shortcut, my professors told me these shortcuts about. You need to know SPTV, which is the Singapore TV. Singapore TV. SPTV. So SPTV. Whenever you draw this kind of line, you have to draw another line so that the last two term is in becomes common, right? So if this common side comes left or right, so a negative charge has to be given, right? And if this common side is upper or below section, then there will be no negative charge, that is positive charge. So I am showing you what I am telling about. Say the relation will be like this: delta S del P, this will be first, this will be second, and this will be third. First del S del P T equals to, as this side is common, so one negative will be included, negative. Now from that direction, del V by del T and constant P. Okay, so take another example. Suppose we are taking this direction and this direction, so what will be the relation? The relation will be del S del Vt equals to, as below side is common, so there will be no negative charge, that is positive, or you may ignore this, and del P del T by V. So this will be another relation. So in this way you can get every relations from this, and you can verify which options are correct. Okay, so from this, option C and option B will be correct. Okay, so the next question coming: 2 moles of an ideal gas is expanded isothermally and reversibly from 5 to 1 bar. The change of entropy. So here isothermal expansion of ideal gas. So you need to know the relation, that is delta S isothermal reversible, okay, and ideal gas. So delta S in isothermal reversible ideal, which is the relation, that is NR ln V2 by V1, and for ideal gas here V2 V1 are not given, so you need to convert V1 and V2 as P1 by P2. So here N is given, that is 2 moles, R is given, P1 is given, and P2 is given. If you put the value, you will get the value of delta S. Okay, and that will be the answer. Okay, now coming to JAM 2016. Okay, so the first question was entropy order, okay, of various state of CO2. So CO2, when it is gaseous, it has highest entropy, then CO2 is liquid, and then CO2 is solid. It's very easy question. You may face this kind of questions also in JAM 2019. So why is this? Because in gaseous state, the disorderness of the system is maximum. Liquid state, it's medium, and it's in solid state, it's lowest. Okay, as disorderness measures the entropy, so entropy will be maxima and entropy will be minima. So this will be the correct order of entropy, right? So coming to next question. The next question was the enthalpy of formation of CH4, C and H are given. So here I want to tell you, I have done the math in my PDF, so check there. You will definitely understand what I have done there, right? So it's very easy, and that's why I don't want to show you, because it will make the video very lengthy. Okay, so check there, you will get. Okay, the next question was from JAM 2017, and the first question was intensive variables are temperature, volume, pressure, density. So it is a MSQ question. So the correct options are temperature, pressure, and density. And why is that? Intensive variables means variables those are not dependent on mass. Temperature is not dependent, density is not dependent, because you know that density equals to mass by volume, and mass is extensive property and volume is extensive properties, and ratio of two extensive property is intensive. So density is intensive, right? And also, why? You may ask why pressure is intensive, because you know the relation, and you know pressure is dependent. You may think that pressure is dependent on N, but here is a trick. If volume is constant, then pressure is dependent on mass. So if volume is constant, then pressure is extensive. If volume is not constant, or nothing is said about volume, then pressure is intensive, because if you increase the pressure, volume will be low, and if you decrease the pressure, volume will be high. So these two are self-dependent, right? So that's why pressure is intensive, as there is no relation between pressure and volume is given. And here it is not said that volume is constant. That is why. Okay. So pressure is intensive. That's why. If volume is constant, then pressure will be extensive, because it is only then mass dependent. Okay. So now coming to next question. The next question from JAM 2017 was, at 298 K and 1 atm, the molar enthalpies of combustion of cyclopropane and propene are given, and the enthalpy change you need to calculate. Okay, the enthalpy change you need to calculate for the conversion of 1 mole of propane to 1 mole of cyclopropane, right? So here only one trick you need to remember. Propene, that is CH3, CH double bond CH2, and cyclopropane, that is CH2, CH2, right? So you know which one is more stable. This one is more stable and this one is less. So the enthalpy change from this to this. So this will be higher energetic as less stable, and this will be lower energetic, that is more stable. Okay. So whenever you need to calculate the enthalpy change, so if we subtract the value kilojoule per mole, and this will be the answer. Okay. You can check all of the explained answers in my blog. Okay. So check the description and go to my blog and download the PDF, and you will get everything. And also I have added a PDF file for the chemical thermodynamics study material, and you can check and print out the PDF and read all of the topics whichever IIT JAM is included, right? So the next question coming from 2017 is isothermal reversible compression, isothermal reversible and compression for ideal gas, in which, or ports 1 mole ideal gas, in which the pressure of the system increased from 5 atm to P1 is 5 atm, P2 is 30 atm. The entropy change of the surrounding. So here you need to remember only one thing, that for reversible change, the entropy delta S system, and the relation between delta S and system and surrounding is delta S system equals to delta S surrounding, and only one negative charge. So here thus they are related. So you need to calculate the entropy change for the system and then put the value, and the surrounding will be the negative one, the negative value before this value you got from the system. Okay. So the formula, required formula, delta S surrounding equals to minus delta S system, and minus delta S system is equals to NR ln V2 by V1. So here V2 V1 are not given, so NR ln V2 by V1 for ideal gas it will be P1 by P2. So this is the required formula. So if you put the value, you will get the final answer. Now coming to JAM 2018, and the question was the correct expression for reversible adiabatic expansion of an ideal gas. Okay, so for adiabatic, delta Q equals to 0, and here the correct option, you have to know that this is not in equilibrium, so delta G not is equal to 0. So, and also this is not an isothermal process, so delta U not is equal to 0, and this is not isoenthalpic process, so delta H not is equal to 0. But you know the relation as delta S equals to Q reversible by T. So here for adiabatic process, of course Q equals to 0, absorbed heat or heat change equals to 0. That is why delta S will be 0, right? So delta S equals to 0 will be the correct option. Okay. So now coming to the next question. The correct expression for isothermal expansion of 1 mole of ideal gas. So you have to know the relation, all of the relation, that is Hellman's free energy relation, delta H, delta G, delta S, and you can see the options right on the screen. Okay, so I am just telling you the options. So the correct options will be A, that is, it is A, this is B, this is C, this is D. So the correct options will be delta A equals to RT ln V initial by V final, delta G equals to RT ln V initial by V final, and delta S equals to R ln V final by V initial. So you have to know all the relations. Okay, so you can check the relations, and you can also derive the relations from the PDF. Okay, so check there. Now coming to next question. There is a reaction and the value of delta U for the reaction is given, and you have to calculate the value of delta E. So you know the relation delta is equals to delta U plus delta N RT. You can calculate delta N as it is minus of R. You know temperature is given, delta U is given, you need to calculate delta E. Here one thing is important, that is I have said in my previous video that you need to consider kilojoule joule conversion. Okay, so R is here as joule, delta U as kilojoule. So first convert it as joule, then calculate the value delta is in joule, then convert the value in again kilojoule. Okay, so here you need to consider all these things, so take care of them. And now coming to next question. The next question was H2 plus half O2 equals to H2O, and here temperature is given, in entropy of the three, oxygen, hydrogen and H2 is given. So and here also enthalpy is given in kilojoule. So first convert it in joule, then go ahead, right? So you need to calculate the delta is 0 universe, that is delta is 0 system plus delta is 0 surrounding. Okay, so delta is 0 surrounding has the formula minus delta is 0 by T. So put the value delta is and temperature, you will get delta is surrounding. How can we calculate delta is system? So this will be summation of product delta is 0 minus summation of reactant delta is 0. Okay, so this is given, the entropy of the H2 is given, and the entropy of the H2 and O2 also given. So just put their value here and you will get the delta S system, and then add both the value and you will get the delta S universe, which will come as 788 joule mole inverse Kelvin inverse. Okay, so this will be the correct answer. Okay, so after solving all the previous year questions, let's talk about the important topics whichever you need to read. So you need to read from first law of thermodynamics, that the topics are isothermal and adiabatic process, and from this you have to calculate the Q, that is heat, required heat, work done, W, delta U, that is energy change, internal energy change, and enthalpy change, delta H, for ideal and real gases, and in what processes. The processes are reversible processes, irreversible processes, and also free processes. Okay, so you have to remember those by tricky method. So just read the PDF whichever I will provide you in the blog. So just check the PDF and you will get everything about the different process. Okay, so next coming to next topic, that is entropy calculation in different processes. It is also in the PDF. Okay, and then coming to thermochemistry math. From thermochemistry, a different kind of math whichever you have done in your 11th or 12th standard, those are enough actually. Okay, so you have to do those, and then coming to Maxwell relations, and I have already told you about the Maxwell relations. How can we remember all those? Okay, and you will get the relations also in the PDF. Okay, so next coming to Gibbs free energy and Hellman's work function. Okay, and finally some basics thermodynamics, that is path and state dependency, extensive intensive property, cyclic rule, TS diagram, it's very important, you need to remember. Then heat engine, that is Carnot heat engine, and also finally refrigeration cycle. So these topics are very important, and I am not telling you to ignore anything from this chapter, because I have already told to ignore some topics in the previous solid state, the heat capacity of solids for example, and some others from other chapters, but I will not recommend you to ignore anything from this chapter, because that is a very important chapter, and you have already seen that in the last few years already almost 4 to 5 questions, at least 4 or 3 questions came from this chapter. So don't ignore anything from this, you have to read this chapter carefully, very carefully. Okay, so just go ahead, and if you have any query, please comment below, and if you cannot comment in the description, so comment in my blog also. so that I can interact with you in a better way. Okay, and if you need much more communication, so just mail me. My email address is this gmail.com, right? So just mail me and I will definitely try to answer your question. Okay, so thanks for watching.